Training.com, CWI prep course. Come visit us at our website at train-eng.com, pronounced training. This is our CWI prep course. This is as you go through some of these videos, these will be some snippets or samples out of our online training course. If you like what you see here in the sample section, come and visit us and take the course. Our CWE online Part A video course, $149. It's self-study CWI exam. Everything's an online video course. CWI prep course, shielded metal arc welding, SMAW, Module 3, Part 13. Learning objectives. In this module, we're going to talk about the basic information involved in shielded metal arc welding, SMAW. We're going to talk about basic welding terminology, basic SMAW equipment, advantages and disadvantages of the shielded metal arc welding process. The shielded metal arc welding process is one of the older processes. Tried and true, very portable, very easily adapted to a lot of situations for shipbuilding, construction, repair, pipelines, power plants. There are advantages and disadvantages to shielded metal arc welding, but when a lot of people think of welding, this is what comes to mind because it is so versatile and so readily available and so well used as a process. Shielded metal arc welding is a manual arc welding process in which heat is produced by an electric arc between a flux-covered consumable electrode and the base metal. The weld pool is protected from atmospheric contamination by a gaseous shield and a fused flux or slag. The gas shielding is the result of combustion and decomposition of the flux. The electrode consists of a cast metal rod and flux covering. The rod, known as the electrode, conducts the electric current to the arc and serves as filler metal for the joint. This is a pretty standard diagram of the shielded metal arc welding process. You can see that the electrode is a covered electrode. It's covered with a flux. There's a metallic wire core. You can see where the metal slag and droplets are melting at where the arc is. You've got a weld pool, the solidified slag. This is how this process works. You've got a metal electrode that's covered with a slag. The older electrode types like 6010, I know this doesn't mean anything to you, but a 6010 electrode is a carbon steel electrode that's covered with a cellulose-based flux. It's one of the first electrodes. At some point when they were discovering arc welding and refining the process, they figured out that wrapping it with newspapers or wood chips or a cellulose-based material would cause a burning, and then when that flux burned, it would kick off an atmosphere, a shielding atmosphere that would keep oxygen and other deleterious materials out of the weld pool. So that's where the fluxes came from. And then as people got more involved and the process became more refined, the fluxes became more sophisticated. You developed low hydrogen fluxes, rutile fluxes, a whole different variety of fluxes for shielded metal arc welding. And then there was different metals that were going to be welded, stainless steels and nickel alloys. And so there's a wide variety of these electrodes for welding all kinds of different materials together. So, but the basics are you've got a piece of metal wire and an electrode covering that can have, burn off for a variety of different effects, shielding, and then adding alloying elements to the weld metal. So, but yeah, this is the basic diagram for the shielded metal arc welding process. Several basic devices are needed to make a manual arc weld. They are the power source, welding cables, electrode holder, ground connection, and electrode. The power source provides the electrical energy to melt the workpiece and the electrode. The power source must permit control of the arc characteristics as required for a specific job. The welding cables connect the electrode holder and ground clamp to the power source. The cable carries the electrical current from the power source through the arc to the base metal being welded. The ground cable connects the power source with the workpiece, thus completing the electrical circuit. The ground connection must be good to prevent arc blow. The electrode holder is merely a clamping device for grasping the electrode. The electrode is part of the electrical circuit and it is consumed during the welding process. It fills the joint and thereby becomes a part of the weld. This slide you can see a couple of examples of shielded metal arc welding electrode holders. The bottom left hand corner you can see some examples of shielded metal arc welding electrodes, and you take the electrode, you put it in the holder and strike an arc, and the picture you see there with the individual making a fillet weld there, that's what shielded metal arc welding is all about. Using an electrode to deposit sound weld metal into a weld joint. Factors that affect electrode selection. Type of base metal. You absolutely have to know what the base metal is before you start welding on it. Nothing will create bigger problems down the road than not having a positive identification of the base metal. This also can drive welders and welding engineer type people absolutely insane. If you come up to them and say, hey, just weld this, and the welding engineer asks the person who needs it just welded, what is this? And the person needing it welded says, I don't know, just weld it. No, it doesn't work. You need to know what the base metal is before you start, or have a general idea. You might not need certified material test reports, but it's a good idea to know what you're welding on. The metal thickness is another good idea to have, because shielded metal arc welding, there's different electrodes that perform differently on different thicknesses of material. So some are better for sheet metal, some are better for heavy sections of material. Material thickness. Groove design, what's the groove going to look like? What are we trying to accomplish here? The joint alignment, another one. What are we trying to get accomplished here? Available welding current. How big a power supply do we have? How big a welding electrode can we use? Is this going to be a 4-inch thick weld and we're going to do it on a flat position and just be able to pour the coals to it? Or is it something where we've got really small power supply and we're going to have to chunk along at a slower rate? So available weld current is another factor that's going to affect electrode selection. Skill level of the welder is also going to affect electrode selection. Not everybody can weld with every type of filler material, so you need to know who you've got working for you and who's going to be doing the welding. Some more factors that affect electrode selection. Welding position. Not all welding electrodes are designed for all positions. So if you're doing an overhead weld, you're not going to be able to utilize a welding electrode that only runs in the flat position. So you're going to need to determine what your position is, and then is this electrode suitable for that position. The rate of weld deposit, do we want something that's really going to have a high deposition rate? What are we looking for? Once again, the position is going to dictate the rate of the weld deposit. You're going to be able to put weld metal in faster in the flat position than you will in the overhead or the uphill or downhill position. Depth of penetration. what kind of material are we welding on? Is it a sheet metal weld? Well, a lot of times on a sheet metal weld, you might not want something that's really going to have a lot of penetration. Weld bead finish, this is, how smooth is the weld bead going to be? What are we looking for? Impact strength definitely comes into play, especially in industries such as oil and gas or mining, and especially in locations where the environment's going to play a role and you're going to have very cold temperatures. A lot of steels don't react well to really cold temperatures. Well, most don't. It just depends on what the material is. So impact strength, you need to see how much impact energy this material can absorb before it breaks. Corrosion resistance. If you've got a corrosion, let's say you're making a weld on some corrosion resistant steels, you probably want a weld material that's going to match up with the corrosion resistance of the base metal. So, or you're not going to also not going to want a situation where you put in a filter. In the pictures on this slide, you can see a couple examples of shielded metal arc welding electrodes. The bottom right hand corner, you can see some various carbon steel electrodes that are used for they're low hydrogen electrodes. We won't get into the nomenclature, but you can see how the flux is, and then at the far right hand edge of the picture you can see that there's exposed metal, and that goes into the electrode holder. In the upper left hand corner you can see some pretty common packaging types that for shielded metal arc welding electrodes. You've got a 50-pound can and then a couple of smaller containers, and you can get it in boxes depending on how much you need and how much you want. Generally it comes in 50-pound hermetically sealed containers. This is to keep the moisture out. You don't want, if you've got a low hydrogen electrode, you don't want a lot of moisture getting in there and messing with the ability of the flux to deposit low hydrogen weld metal into a weld joint. So shielded metal arc electrodes continued. The electrode's got to be compatible with the base metal. In a previous slide we mentioned you got to know what your base metal is. You can't just grab a random piece of filler material and start welding on something. The tensile strength should match up with the the base material. What's the end use of this component? So you have to know what your base metals are. Tensile strengths, metallurgically, chemically, all these things need to match up when you're making a weld. And you might be able to goop some weld in there, and I say goop it in there and get it to stick, but it might not last very long, or there could be cracking problems or whatever. So you need to do your homework, and the electrode needs to be compatible with the base metal. Shielded metal arc welding electrodes are available for different metals. Your garden variety carbon steels, your low alloy steels, corrosion resisting steels, cast irons. Yeah, you can weld on cast irons. It can be painful, but there's a whole assortment of welding rods that are produced specifically for making repairs on cast iron materials. Aluminum and its alloys can be welded. There's some shielded metal arc welding electrodes that you can make repairs to or weld on aluminum alloys. Copper alloys and also nickel and nickel alloys are readily welded with shielded metal arc welding electrodes. As we mentioned before, there's going to be a layer of slag. When you're done making a weld pass with shielded metal arc welding, there's going to be a layer of semi-mineral type slag on the surface of your weld bead. So you need to remove that. And the methods for removing it are using a slag hammer or a slag pick, possibly a grinder, and a wire brush. These are the tools of the trade for slag removal. You can get a, like a chipping hammer, a pneumatic chipping hammer, or chipping gun sometimes are used, but for the most part, these are the tools of the trade for removing slag. So you can get final inspection done, or you can, if you've got another weld bead to put on another pass, then you knock all the slag off and you use these tools to knock the slag off and prep the weld for another pass of weld filler material. The advantage is SMAW. The equipment is inexpensive. A few hundred to a few $1,000s you can have shielded metal arc welding equipment. Put it on the back of a truck depending on what you want. The equipment's portable, not very big, size of a small, beer cooler to, something, the size of half the size of a refrigerator. Applications are simple and adaptable to the job requirements. You can use them with all kinds of filler metals, carbon steel, stainless steel, nickel alloys, hard facing rods. There's numerous variants that you can use, and you can make some really high quality welds. A lot of x-ray quality welds on pipelines and power plants and nuclear situations are done with shielded metal arc welding. Very versatile process. Disadvantages of shielded metal arc welding. It's a really good process, but like anything else in life, there are going to be disadvantages to it. The disadvantages of shielded metal arc welding, it requires slag removal. So your protective slag that you were using to provide protection from the atmosphere while you're welding now is a rock hard slag that needs to be chipped off and wire wheeled off. So when you put the next weld bead on, you don't have slag inclusions when it goes to get x-rayed or ultrasounded. Harmful gases can be produced when the flux melts. There's all kinds of research being done on the effects of welding smoke on human physiology. I'm not going to get into that here, but it's something you need to be cognizant of if you're going to be welding. Ventilation is key when using shielded metal arc welding. There's a whole industry of people that make smoke suckers to, suck up the bad materials that are in the smoke. Changing electrodes can slow down the process. This gets back into chipping off the slag and putting another electrode in. Low deposition rates. It's just a slow process, but if you need high quality welds or a certain mechanical or chemical property in the weld metal, this might be your way to do it, but it's going to take you a long time to do it. And somewhat high skill level for welders. This is not something you turn the rookies loose with. Shielded metal arc welding takes a while to figure out, so it's not something that just anybody picks up, and it's not like gas metal arc welding where you just pull a trigger and you're puking out metal. It takes a while to figure out what you're doing, especially out of position welds with the shielded metal arc process. A brief summary here of the shielded metal arc welding process. SMAW is the most versatile welding process and least costly of all the welding processes. It is an all-position welding process when the proper electrode diameter and type of electrode are selected for different positions. Shielded metal arc welding can be applied to most metals except those with low melting points such as zinc, lead, and tin. The process has a couple of major disadvantages: low productivity due to the limited length of the electrode and the necessary deslagging of every weld pass. But other than that, it's a pretty strong welding process, which is why it's used worldwide. Pipeline, shipbuilding, construction, you pick it, you're going to see it. You're not going to see it too much in making cars due to the speed and the slag issues, but very solid weld process that has a lot of different uses in a lot of different industries. Unlike a lot of other programs, we've got it set up so that you can do it a la carte. If you only need to, we've got different parts of the CWI course broken out. So if you don't need to sit through and take safe practices for welding inspectors, or you have some strengths that you know of and you want to streamline the process and only hit the sections where you don't really have a strong background or a great deal of proficiency, our program is set up so you can take some of these parts of the CWI online course a la carte. Pick and choose, put together what you want. Leave the rest, like a Chinese food buffet. We've got one section where it's questions, questions, and more questions. We've got a whole number of CWI self-study question bank, $40. Come on in, take it, take a look, see. If you just need questions, if you sat through another course and you just want to keep hitting the material, check out our question bank, $40.